Hey, curious minds, have you ever wondered, why does matter exist at all? It's one of the deepest questions in all of science, and it's something that has puzzled humans for generations. When you look around at the world, at the stars, at yourself, it's easy to take for granted that stuff is just here. But why? Why is there something instead of nothing? Not just what it is, but why anything is here in the first place. Imagine a universe with no stars, no planets, no atoms, just a vast, endless emptiness. It's a mind-bending thought, and yet it's a scenario that almost happened. Today, scientists have stumbled upon a surprising new clue that might bring us closer to answering this cosmic mystery. This isn't just another small step in physics. It could be a giant leap in our understanding of the universe. Let's dive in and see what they found. About 13.8 billion years ago, the universe burst into existence in the event we call the Big Bang. In that first instant, unimaginable amounts of energy transformed into particles of matter and their opposites, antimatter. But here's the puzzle. According to the laws of physics, matter and antimatter should have been created in equal amounts, and when they meet, they annihilate each other in a flash of energy. So, if everything was balanced, why didn't it all just cancel out, leaving behind a cold, empty void? So why do we still exist? Why is there a universe filled with galaxies, stars, planets, and life, instead of nothing at all? This is one of the greatest unsolved mysteries in science. Why is there more matter than antimatter? What tipped the scales in favor of matter, allowing everything we know to exist? Scientists have been searching for answers for decades, and the quest has led them to some of the most advanced experiments ever built. To solve this cosmic riddle, scientists have been smashing particles together in huge colliders, like the Large Hadron Collider. These machines recreate the conditions of the early universe, allowing researchers to study the tiniest building blocks of reality and the subtle differences between matter and antimatter. They've been hunting for tiny differences in the way matter and antimatter behave, differences so small they're almost impossible to detect. But even the slightest imbalance could explain why matter survived and the universe exists as we know it. This phenomenon is called CP violation. In simple terms, it means that the laws of physics aren't perfectly symmetrical when it comes to matter and antimatter. It's rare, but it means matter and antimatter don't act exactly the same, giving matter a tiny edge. Over billions of years, that tiny edge could have made all the difference, allowing matter to win out and form everything we see today. But until now, the amount of CP violation observed wasn't enough to explain the huge surplus of matter in the universe. The numbers just didn't add up. There had to be something more, something we were missing. And here's the big news. A breakthrough that could change everything we thought we knew about the origins of matter. Recently, scientists detected unexpected results in neutrino experiments. Neutrinos are tiny, ghost-like particles that barely interact with anything. They can pass through entire planets without leaving a trace. For years, they were thought to be almost irrelevant to the matter-antimatter mystery. But now, they're at the center of the story. These results hint at a new kind of CP violation, potentially much stronger than anything seen before. If confirmed, this could be the missing piece of the puzzle, the reason why matter triumphed over antimatter in the early universe. Neutrinos have a strange ability. They can oscillate or change between different types as they travel through space. This shape-shifting behavior is unlike anything else in the particle world, and it might hold the key to understanding the universe's imbalance. The new findings suggest neutrinos might behave differently than their antimatter counterparts, antineutrinos. This difference could have tipped the cosmic scales, giving matter the upper hand and allowing galaxies, stars, and life to form. It's a fresh lead, and it's sending shockwaves through the world of physics. Now, scientists are racing to confirm these results with bigger, more sensitive experiments around the world. International teams are collaborating, building massive detectors deep underground, and pushing the boundaries of technology to catch these elusive particles in the act. If this new CP violation holds up, it could rewrite our understanding of why the universe is made of matter, and why we are here at all. It could even open the door to new physics beyond what we currently know. Mind-blowing, right? The universe might still be keeping secrets, but step by step, we're uncovering them. Every new discovery brings us closer to answering the ultimate question: why do we exist? The journey is far from over, and the next breakthrough could be just around the corner. If you love diving into the biggest cosmic mysteries, hit that like button, subscribe, and ring the bell. so you never miss the next discovery. Stay curious and thanks for watching.